August 2015, Geometry Common Core Regents Exam, Part 1, Answer Key. Part 1. Answer all 24 questions in this part. Each correct answer will receive 2 credits. Utilize the information provided for each question to determine your answer. Note that diagrams are not necessarily drawn to scale. For each statement or question, choose the word or expression that, of those given, best completes the statement or answers the question. This is worth a total of 48 points. Use the space for computations. Number 1, a parallelogram must be a rectangle when it's 1. Diagonals are perpendicular. 2. Diagonals are congruent. 3. Opposite sides are parallel. And 4. Opposite sides are congruent. So it can't be choice 1 because the only figures from the parallelogram family that have diagonals that are perpendicular are a rhombus or a square. So that excludes a rectangle. And as for diagonals that are congruent, a rectangle does have diagonals that are congruent along with a square. Opposite sides that are parallel, well, yes, a rectangle has that, but so do all the other figures in the parallelogram family. So it doesn't isolate a rectangle in order for that to be the answer. And as far as choice 4, opposite sides are congruent, is the same situation as choice 3. All the figures in the parallelogram family have this criteria, so it does not isolate the rectangle as the only figure that has this. So the uniqueness that a rectangle has, that is the obvious answer, is choice 2. Number 2, if triangle A prime B prime C prime is the image of triangle ABC, under which transformation will the triangles not be congruent? So the only time figures would not be congruent is if a non-rigid motion transformation took place, and a non-rigid transformation is a dilation. That would be choice 3. This is a rigid motion, a reflection, a translation is a rigid motion, and so is a rotation. So they would all create congruent figures. Number 3, if the rectangle below is continuously rotated about side W, which solid figure is formed? So if we rotated this figure about side W as if we had a pole here, we would end up with a figure that is a very wide cylinder. Number 4, which expression is always equivalent to sine of x? Well, we know that sine of x is equal to cosine of some angle. That is the other acute angle in a right triangle because they are cofunctions. So if I have sine of x, then the other angle has got to be the difference of 90 in x. So the sine of x is equal to cosine of 90 minus x. Number 5, in the diagram below, a square is graphed in the coordinate plane. A reflection over which line does not carry the square onto itself? So if I draw a line where it has choice 1, x is equal to 5, so where x is 5, I draw my dashed line, and if I reflect this figure over the dashed line, I get the square over here. So that does not reflect on itself. But let's just prove the others to be not the answer we're looking for. Where y is equal to 2, that would be right here. If I fold the square along this line, it would map onto itself. So that works. where y is equal to x is this diagonal line here. And if I fold along that line, the square would map onto itself, so that does not work. If I solve this equation for y, and I get y is equal to negative x plus 4, and I graph that, and I apply the slope down 1 over 1, down 1 over 1, I get 1, 2, 3, 4. I'm a little off there. Let me fix that. My y-intercept is 4, so 1, 2, 3, 4, down 1 over 1, down 1 over 1. I get this line here, and if I fold the square along that line, I would have it map onto itself, so the clear and obvious answer is, in fact, choice 1. Number 6, the image of triangle ABC after a dilation of scale factor k centered at point A is triangle ADE, as shown in the diagram below. Which statement is always true? So with regard to similar triangles, let's see what we can figure out here. For choice 1, if we double line segment AB, that's equal to AD, well, that's obviously not true because we don't know what the scale factor is, so we can't say that it's double that. So it all depends on the scale factor. AD is perpendicular to DE, that's plausible. AC is equal to CE. No, we can't conclude that. We don't know if that is mid-segment in that regard. And choice 4, BC, is parallel to DE. So between 2 and 4, AD is perpendicular to DE. Well, it could be if we were told in some regard that it was, but we just can't conclude that because it looks like a right angle. How do we know it's not an 89-degree angle versus a 90-degree angle? We can't really look and say. But what we can say is that BC is parallel to DE, and I'm sticking with that answer. Number 7, a sequence of transformation maps rectangle ABCD onto rectangle A double prime, B double prime, C double prime, and D double prime, as shown in the diagram below. Which sequence of transformations maps ABCD onto A prime, B prime, C prime, D prime, and then maps A prime, B prime, C prime, D prime onto A double prime, B prime, double prime, C double prime, D double prime. So we're going from here to here, and that's an obvious reflection over the x-axis. And then going from here to here, we have a rotation. So a reflection followed by a rotation is choice 1. Number 8, in the diagram of parallelogram FRED shown below, line segment ED is extended to A, and line segment AF is drawn such that AF is congruent to DF. So I'm going to designate that right now. If the measure of angle R is 124 degrees, what is the measure of angle AFD? So we're looking for this angle measure here. So using what I know about parallelograms, opposite angles are in fact congruent. So this is 124 degrees. These two angles are linear pairs. So if I subtract 124 from 180, I get a difference of 56. Knowing that these two sides are congruent originally, then I can say that this angle is also the same because opposite congruent sides are congruent angles. And then I find that the sum of these two angles, 56, angles A and FDA, are 56. So I subtract 112 from 180, and I get 68. So that is the measure of angle AFD. Choice 3. Number 9, if x squared plus 4x plus y squared minus 6y minus 12 is equal to 0, is the equation of a circle, the length of the radius is, we're going to have to use completing the square, procedures. So I'm going to take 1/2 of 4 and square it, which is 4. What I do to one side, I have to do to the other. And I take 1/2 of 6, which is 3, and square it. And I add 9 to both sides. So the output here is 25, which means the radius is the square root of 25, which is 5. Number 10, given line MN shown below with M -6, 1 and N 3, -5, what is an equation of the line that passes through the point P 6, 1 and is parallel to MN? So in order to find a line that goes through this point and is also parallel to MN, I would need to know what the slope is of MN. And there's one of two ways in which to find the slope of MN. I choose to do the rise over run way, or you could just use the slope formula of using the endpoints M and N, change of Y, over the change of X. So that's your choice. So to go from one point to the next, I obviously have a negative slope, so I can rule out these two immediately. Okay, so to go from M to this point right here, we go down 1, 2, and we go over 1, 2, 3. So the slope of MN is equal to -2/3. And since I have the point P, I'm going to plug that into y is equal to mx plus b. So parallel line has equal slope. I'm going to use -2/3. I have a value for x, which is 6. I'm looking for its y-intercept, which is b, and I have my y value of 1. That's x, and this is y. So 3 goes into 6 2 times. I have 1 is equal to -4 plus b. Add the 4 to both sides, and I get 5 is equal to b. So my new equation for the line, my y-intercept is 5, and my slope that's parallel is the same as -2/3, so that's choice 1. Number 11. Linda is designing a circular piece of stained glass with a diameter of 7 inches. She is going to sketch a square inside the circular region. So we have a circle and a square inside that circle. We have a diameter from diagonal, which creates a diagonal from corner to corner of the square, is 7 inches. We know that a square has 4 right angles, so we have 2 right triangles. And to the nearest tenth of an inch, the largest possible length of the side of the square is. So since we know that a square has the same values for the legs, or the sides in this case, I can plug it into a squared plus b squared equals c squared, the Pythagorean theorem, and get 2x squared is equal to 49. So x squared is equal to 49 halves, and then I take the square root of both sides in order to reverse the process of squaring a number, and that should give me approximately equal to 4.9. And that is choice 2. Number 12. In the diagram shown below, line AC is tangent to circle O at A and to circle P at C. Line OP intersects line AC at B. OA is equal to 4 and AB is equal to 5 and PC is equal to 10. What is the length of BC? So BC is what we're looking for. This looks like a complicated problem that really isn't. It's just a similar triangle. And what you need to keep in mind is that you've got corresponding sides and angles. So I'm going to redraw the triangles. You might see it a little bit better. Okay, make sure you got the corresponding angles in correct spots. If you were to take the smaller triangle and lay it on top of the larger one, where would the corresponding angles go? So OA is 4, BA is 5, BC is X, and PC is 10. So we have 5 over 4 is equal to our proportion of X over 10. Cross multiply 50 divided by 4, and we get 12.5. So that's choice 3. Number 13. In the diagram below, which single transformation was used to map triangle A onto triangle B? So there's not a line reflection, or else we would have a picture that looked like this. It looks like it's a rotation. Dilation, well, the length is preserved, so it can't be a dilation. And a translation, we didn't push it anywhere, so rotation is the obvious answer. Number 14. In the diagram below, triangle DEF is the image of triangle ABC after a clockwise rotation of 180 degrees, and a dilation where AB is equal to 3, BC is equal to 5.5, AC is equal to 4.5, DE is equal to 6, FD is equal to 9, and EF is equal to 11. Which relationship must always be true? The measure of angle A over the measure of angle D is equal to 1/2. Well, we don't even know what the angle measures are to even say whether or not they have a ratio of 1/2. So in this particular case, we can't say that. So the measure of angle C to the measure of angle F is 2 to 1. Same situation as number 1. We don't even know what the angle measures are to even say that it has that ratio, so that can't be true at this point. For number 3, if we set up the proportion, the measure of angle A over the measure of angle C is equal to the measure of angle F over the measure of angle D, well, we can't set up that proportion, and the reason as to why is because although the measure of angle A and F proportionally don't work out correspondingly, what you should have here in place of that is the reverse, the measure of angle D in terms of corresponding angles over the measure of angle F. Then we could prove that to be true. Okay, and so for number 4, the measure of angle B over the measure of angle E, okay, those correspond, is equal to the measure of angle C over the measure of angle F. Yes, those are corresponding angles, so this proves to be true. Number 15. In the diagram below, quadrilateral ABCD is inscribed in circle P. What is the measure of angle ADC? So the important information that I'm given is that I have a quadrilateral ABCD, and I'm looking for this angle right here. And what I do know about all angles in a quadrilateral is that their sum is equal to 360. So if I subtract 110 and 72, from 360, I get a difference of 178. So that means the sum of these two have got to be equal to 178. And as you can see, this angle is more acute than this one here. It can't be 72 degrees because we don't know if these two legs are equal, A, B, or DC. And it doesn't look like that they are. So this one looks like it's obtuse, so it could either be 108 or 110. However, I don't think that all these angles are equal. So as a result, my best educated guess is 108 degrees. So if this is 108, then this would work out as 70, and then the whole entire sum of the quadrilateral would make 360. So reasoning this out seems to be 108 works out perfectly. Number 16. A hemispherical tank is filled with water and has a diameter of 10 feet. If water weighs 62.4 pounds per cubic foot, what is the total weight of the water in a full tank to the nearest pound? So the volume formula for a hemispherical tank, that's 1/2 of a sphere, is 1/2. The volume formula for sphere is 4/3 pi r cubed. So we get 4/6 pi. The diameter is 10, so that means the radius is equal to 5. So 5 cubed is equal to 261.8, and then I multiply 62.4 pounds and get a product of 16,336. Number 17. In the diagram below, triangle ABC is similar to triangle ADE. Which measurements are justified by this similarity? So in checking with these measurements, I need to set up the proportion and see where the product of the means is actually equal to the product of the extremes. So if AD is 3, AB is 6, AE is 4, and AC is 12. So 3/6 is equal to 4/12, and 24 is not equal to 36. So choice 1 does not work. So 5/8, is that equal to 7/10? So 50 does not equal 56. And of course what I'm doing is cross multiplying here, as you probably already knew that. Is 3/9 equal to 5/10, and 30 is not equal to 45, so this one doesn't work. So it's got to be choice 4, but let's just prove it to be true. 2/6 is equal to 5/15, and yes, 30 is equal to 30 indeed, so this proves that we've got the similarity. 18. Triangle FGH is inscribed in circle O. The length of radius OH is 6, and FH is congruent to OG. So FH is congruent to OG. And we know OG to be a radius, and we are given OH. So this is 6, this is 6, and this is 6. What is the area of the sector formed by angle FOH? Okay, so in order to find the area of the sector, it's the angle measure of the area of the sector divided by 360, that's the whole, times the area of the entire circle, pi r square, and that's equal to area of the sector. So I have the radius as 6, And I need to find the angle measure, which we can do because all three sides are equal. That means we have an equilateral triangle, and in that case we have 60-degree angles. So we're looking for the area of the sector for this right here. So this is 60 degrees right here. So 60 divided by 360 is equal to, this is times 36 pi. 36 goes into 360 10 times, and then 10 goes into 60 6 times, so we get 6 pi as a result. Number 19. As shown in the diagram below, AB and CD intersect at E, and AC is parallel to BD. Given triangle AEC is similar to triangle BED, which equation is true? CE over DE is equal to EB over EA. Okay, this proportion isn't going to work out because they started with CE and they went to the other triangle DE, so they should have had that equal to the same part, which is EA in here over EB. Would make much more corresponding side sense. AE over BE is equal to AC over BD. Okay, that looks like it works. I'm going to prove the other ones to be not true and make sure that choice 2 is my final answer. EC over AE is equal to BE, okay, over ED. Alright, we're not using corresponding sides correctly here, so EC over AE, then we should go with DE or ED over BE would work. And ED over EC is equal to AC. So ED of the small triangle over EC of the large triangle is equal to AC. That's back to the large triangle, so we need to switch this. It would have to be BD over AC for this proportion to work, so choice 2 is the obvious answer. Number 20. A triangle is dilated by a scale factor of 3 with the center of dilation at the origin. Which statement is true? The area of the image is 9 times the area of the original triangle. The perimeter of the image is 9 times the perimeter of the original triangle. The slope of any side of the image is 3 times the slope of the corresponding side of the original triangle. And 4, the measure of each angle in the image is 3 times the measure of the corresponding angles of the original triangle. So anything that's dilated with regard to angles, angled measures are preserved, so this does not work at all. The slope of any side of the image is 3 times the slope of the corresponding side of the original triangle. We have not talked about or done anything with regard to that, so that doesn't apply. The perimeter of the image is 9 times the perimeter of the original triangle. It's not 9 times, it is 3 times, so that's not going to work. And the area of the image is 9 times the area of the original triangle. Yes, we go with that as far as area is concerned because if the scale factor is 3, we square that and we do end up with 9, so this works. 21. The Great Pyramid of Giza was constructed as a regular pyramid with a square base. It was built with an approximate volume of 2,592,276 cubic meters and a height of 146.5 meters. What was the length of one side of its base to the nearest meter? So as far as pyramids are concerned, especially with the square base, we know that the volume formula is equal to 1/3 times side square which is the area of the base times the height. So we're looking for the length of the side, and we know that the volume is this rather large number that's given. So since 3 is being divided on one side, I'm going to multiply that out, and I'm also going to divide out 146.5 because that's being multiplied, and that's equal to side square. So in order to reverse the process of squaring a number, I'm going to take the square root. So the side to the nearest meter is equal to 230. So that's the length of one side. Number 22, a quadrilateral has vertices with coordinates -3, 1, 0, 3, 5, 2, and -1, -2. Which type of quadrilateral is this? I'm a very visual person, so I would probably go ahead and graph this. And as you can see, you definitely don't have equal sides to cause a rhombus. It doesn't appear as though you're going to have opposite sides congruent to cause a rectangle, with also right angles for all 4 angles. It's very clear that you don't have equal sides, so a trapezoid looks like the apparent answer. Number 23. In the diagram below, triangle ABE is the image of triangle ACD after a dilation centered at the origin. The coordinates of the vertices are A00, B30, C450, D06, and E04. The ratio of the lengths of BE to CD is, well, if we count up, we have 4 and 6, and here we have x value of 3, and this C is at 4.5. So if we take 4 over 6, and we set that equal to 3 over 4.5, and each one of these reduced to 2/3. So the ratio of the lengths is 2/3. Choice 1. Number 24. Line y is equal to 3x minus 1 is transformed by dilation with a scale factor of 2 and centered at 3, 8. The line's image is... So when we have a transformation by dilation of a line, we know that we're going to get a line that's parallel. And since we have a scale factor of 2 and it's centered at 3, 8, this value is a center of dilation that is contained in the line. And as a result, the y-intercept remains unchanged. So we get the same line back. Y is equal to 3x minus 1, which is choice 4. That concludes part 1 of this Geometry Regents exam for August 2015.